Hey everybody, today we're going to work our way through Imperial Measurement. So you can see on the screen, we've got a snippet, a little part of a ruler that shows our Imperial Measurement. And specifically, you can see down to your 1 inch. So when we talk about the Imperial system and we're talking about length, inch is the smallest whole unit that we use. And then what we end up doing is we end up breaking down inches into its parts. So what I want to spend some time doing is just making sure that we are comfortable to read that Imperial Measurement ruler. So if you take a peek, your ruler is designed to show you different fractions of an inch based on how long the lines on that ruler are. You'll notice that my inch, if you can see that green marker come in on the bottom, the length of that line then dictates an inch. So if I just highlighted, any line that is that long shows inches. Within that then, we start to break down inches into smaller and smaller and smaller bits. The length of the line denotes how small the fraction of an inch it is. So if we look at the next longest line, and I'm just going to highlight that one in purple, that line then would represent the next biggest section of a breakout of your 1 inch. So that would represent 1/2 of an inch, right at that line right there. You'll notice that that length plus that length, they look pretty equal to the eye. 1/2 of an inch plus another 1/2 of an inch gets me up to 1 whole inch. So what we end up doing then is just continually breaking down into fractions of an inch. So if we look at our next longest line, and I'm going to highlight that in red, then that becomes 1/2 of a half. And well, 1/2 of a half is 1/4 inch. I think it's also a good time to denote, see those 2 little tick marks up there? That's a symbol used to denote inches. So if you take that 1/4 red and you add another quarter, then 1/4 plus 1/4 gets me up to 1/2. But you'll also notice if I add another quarter, then I get to another quarter measurement. Notice that my 2 red lines are the same length. That's what tells the reader of that ruler that they're the same unit, 1/4 inches. So if I took 1/4 plus 1/4 plus 1/4, then that gives me 3/4 inches. Or if I took 1/2 plus another quarter, that would get me up to 3/4. Now I'm going to write that down for a second, but really it's the 1/2 to get to the purple plus another 1/4. And if you notice pretty quickly, you can change your 1/2 into 2/4. And now that we have common units, we can add them together. So if I get rid of my red arrows, we can see our 1/4 inches, and most rulers then will break down further. So I'm just going to highlight them quickly. If I highlight in orange, then that happens to get me to 1/2 of a quarter, which is 1/8 of an inch. And then if we get down to most rulers' smallest, although not all, some even go further, but most rulers' smallest dimension, you can see with that small little line, that's what's going to get us to 1/2 of an eighth, which is 1/16 of an inch. What you see on your screen now, there is your standard ruler broken into its standard measurements. So what we really want to do is get good at being able to use those measurements to start being able to talk about 2 3/4 inches, 1 3/8 inches, and so on. Let's spend some time doing that. So what you see on the screen right now, I've given you a ruler that shows up to 6 inches. And you can see that all the way down at the end of our ruler. You can see, now that we have something bigger than 1 inch, that all of our 1 inch lines are the same length. And so you can see us adding up to 6. Okay, what I want to do is I just want to take a moment. Can we label the following lengths on that ruler? So what I mean by that is, do just what we did on the last ruler. If you thought that this was 1/2 of an inch, then all we'll do is we'll draw a little arrow to it, and then we would mark it as 1/2 an inch. It's not, so I really hope you don't. But if you did, that's what I'm talking about in terms of label the lengths. Okay? So I want you to give it a shot on your own and try to label those 4 lengths on the ruler. Pause the video now. Okay, we're back. So for us to be able to work our way through a little bit that ruler, I'm hoping that the first one was pretty straightforward since we identified it on the last ruler. That this dimension right there would represent our 1/2 of an inch. So if we got to that, we're good. Check on A. Well, now we take a look at B, and you'll notice that a lot of lengths in imperial take the form of a mixed number. So it's going to tell you how many full inches and then how many parts. So if we take a look at 1.5, then that tells me go ahead to 1 and now add on another 1/2. So that would represent 1 1/2 inches. Okay, hopefully we're good on that one and we can check that one off. Okay, now we start to get a little uglier when we get into 3 7/8. And I'm going to talk to you about a couple different ways that we could get there. If I ask you to identify 3 7/8, a very common approach would be to go ahead and do this. You're going to see the orange at the top. I would travel 1, 2, 3. I'm not really doing that, but it's my eyes that get me to that 3-inch mark. I'm just going to get rid of that orange now, and we can see that we're at this 3-inch point. Now I need to add to that 7/8. And so if I start to move towards 8s, I know that on my ruler, halves, quarters, 8s. There's me dividing by 2, dividing by 2, dividing by 2. So that length of that check mark that you can see now is an 1/8. Okay, let's start moving according to 8s. So all I'm going to do is I'm just going to blow that up a little bit so we can see it a little closer. I now can identify my 8s, and so I'm going to go 1, and then 2, and then 3. See how I'm moving along at that same distance? 4, 5, 6, 7. There is me getting to 7/8. Now, a lot of people are going to look at that, and they're going to go, oh, that was like a lot of counting to have to keep counting up to 7. There's so many different ways to get there. I want to talk to you about a couple other ways. Okay, first off, if we can maybe recognize that 3 7/8 is really 4 inches, then subtract off 1/8 of an inch. Then maybe I go all the way up to 4 as my start, and instead backtrack 1/8 of an inch. I get to the same point. There's a lot of people that will measure 3 7/8 in that way. I'm just 1/8 of an inch short of 4. So go to 4, backtrack it. Okay, there's a lot of other ways to measure that. If we're starting to look at 8s, and you can see that as I circle down in our problem, we're starting to look at 8s. Then maybe what I want to do is I want to fast forward a little bit. So maybe I look and I go, okay, well, I know 1/2 of an inch in 8s is 4/8. Notice that that purple fraction I just wrote down is equal to 1/2 when reduced. So at least I could jump to 4/8, and then I only have to add 1, 2, 3. Ooh, yikes. 1, 2, 3 to get to 7/8. It means less counting. Maybe I even work my way and I say, okay, wait a second. I know that 3/4 is 6/8. And so then all I have to do is just add a quarter. Add 1/8. And that gets me up to 7/8. There are a lot of different ways to get there. Your job, try to get really good at one of the ways and then stretch yourself into others. So what I'm going to do is just shrink that back down to the size we were working with. I'm going to get rid of all of that stuff that I just put on, and I'm going to make sure that we can identify 3 7/8 on our ruler as the instruction said. There is my 3 7/8 inches. Okay, if we've learned something new, then I want us to pause the video and try to find 2 9/16. Okay, try to do it on your own. Pause the video now. Okay, we're back. So if I was going through in green to do that, then maybe I look at it and go, well, 9/16, I don't know. That's not closer to either end, really. So maybe I go to 2. And now I don't want to count up all those little lines and go 1, 2, 3, 4, 5. I don't want to do that. I'm going to delete that and I'll blow it up, but I absolutely don't. Instead, if I have 9/16, well then that's 8/16 plus another one of them. And if you notice, my first fraction is a half. So I could go all the way to a half and then add on one more little bit. I think if I had to measure, where was 2 9/16, that's how I'm getting there. So you can see that green dot is where I'm at for 2 9/16. So I'm just going to identify it, go to 2, jump ahead to 8, 9. I'm going to be very careful with my arrow. There is my 2 9/16. Nice. Okay, I am hoping that we were pretty comfortable to be able to go through and deal with those 4 on a ruler. What I want to do now is just get used to working with these numbers. So if we were to pull out a tape measure, if we were to pull out a ruler, we would be fine to identify the dimensions. If you had to cut a piece of wood, you could use the tape measure and you could mark off the correct distance. Now what I want to do is I want to start working with the values. So take a look at the next section here, problem 2. I've asked you to calculate the following lengths. And you'll notice if you just look at all 3 of these problems, we're getting back to mixed numbers. You notice that you've got your units labeled. We're talking about adding together some inches. This is the way you're going to see this sort of thing represented if we have to put together 2 lengths. I want to walk through this not because I think you can't do this. We should all be capable of being able to add together 2 mixed numbers. But what I want to do is I want to talk about it in a context where you would use it, not some generic thing. So let's walk through A and then B, and maybe you'll see what I'm talking about. If we took a look at A, I could argue that I'm going to really put the blinders on if I did this. Okay, I don't even see the inches. And I know to add 2 things together, I get a common denominator. Well, I love the fact that they're already in halves. My only problem is, shoot, that second one's a mixed number. So what I'm going to do is I'm going to change it to an improper fraction. Okay. If that was the way we view the problem, then I'm arguing to you, you doing this and changing 1 1/2 into 3 halves so that you can get 4 halves down to 2 is you ignoring the context. You just treated those 2 values up top like they were any old values, that they represented anything, and we lost our context. Yes, you could absolutely do the purple. And if all I cared about was whether you got the right answer, then sure. But I want to work my way through this as if we were working through on a job site, in your home, building something, the context where we're going to use it. So I'm going to get rid of that purple because I want to talk about it from that standpoint. When I see that I've got a half plus a whole number and a half, that I'm just going to add together my mixed numbers. So if I was to read that right now, just aloud, then I would say, I have 1/2 inch plus 1.5 inches. Well, 1/2 plus 1/2 is a whole. Add that to my 1, and I get 2 inches. I'm going to reason that out. Okay, hopefully that gives you a little context, a difference. I think it's going to be B that's going to show us that, though. So if I was going to treat B in a generic way, then I might say take 1.5, change it to 3/2, take 3 7/8, so 8 times 3 is 24, add on my 1, 31/8. Now I'm going to get a common denominator so I can change them both into 8ths. That means I multiply my 2 by 4, so I got to multiply my 3 by 4. That's going to give me up to 12/8 plus my 31/8. That gets me to 43/8. Now, 43/8 would be a horrible way to try to find that on a measuring tape. So we would then go ahead and we would put that back together and we'd say, how many times could I take an 8 out of 43? Well, that would be 5 whole times because that's 40. That leaves me with 3/8 left over. Okay, that would be me in this entire process really losing context. I just treated that like it was adding two mixed numbers together. Yes, in the end, where you see that star, I kind of reverted back to my context. Okay, I'm talking about inches here. I don't really want to measure things in 1/8 of an inch when I have so many of them. Okay. I want to get rid of that, but I do want you to just make a note. Hey, we're talking about 5 3/8. And what I'd like to do is I'd like to walk through that whole problem again. So I'm going to erase that whole thing. And then what I want to do is I want to address it in a way where we would measure it. If you had to take a length of 1.5 plus 3 7/8, then what we can do is we can start to add together our whole number of inches with the extra parts. And there's a couple ways we can do that. The first thing we can do is we can just blanketly add our whole number of inches together. So we see that our 1 plus our 3 gives us our 4. Then what we want to do is we want to take the parts of an inch, my 1/2 of an inch in the first measurement, and my 7/8, those parts of an inch, and now we want to add those together. Our problem is they're different sizes. So what we could do then is we could go through it. I'm just going to put a bracket here to make sure we can see it. Is I'm going to change my halves into 8ths, so that's 4 of them. All I did was take that 1/2 and write it in the shared unit, in the same size bit. Then what I could do is go ahead and do the same thing. I've already got my 7ths and 8ths. And so now I'm going to add those things together. That's going to give me 4 and 11/8. Okay, you may notice something really important about that green fraction that I just circled. It's more than an inch. Look at your top number, it's bigger than the bottom. So we have an extra inch in there. So what we can do is we can now change that improper fraction to a mixed number again. My 11/8 is an extra inch, so I'm going to bump my 4 inches up to 5 inches. How many 1/8 of an inch are left over? Well, if I take away the 8 from the 11, then I'm left with 3, and I'm measuring in 8ths. So what that would tell me is on my ruler, on my measuring tape, I would have to go up to 5 and then find 3/8. Okay, that's more practical. That is a practical way for us to work through that problem. And my suggestion to you would be, that's maybe your best way. Now, I do want to walk through that process one other way. I said that you've got options when we deal with this. The other thing that you could work with, and what can happen quite often, if we had the measuring tape in front of us, was we would actually go to the entire first dimension, not just focusing on the whole number of inches part, but the entire thing. And we would go up to 1.5 inches on our measuring tape. Then from there, we would proceed to add. So we would now go and add the next whole number part, another 3 inches. That's going to get us up to 4.5 inches on our measuring tape. Okay, the part that we haven't dealt with was the blued circle part, the 7/8 of an inch. So now from that 4.5, we would have to add on 7/8 of an inch. So on our measuring tape, we would now add as much as we could to get to the next inch. Well, if I'm talking about starting at a half, then a half is 4/8. So when I go to add on my 7/8, I'm going to add on 4 more 8s. That's what gets me up to 5 inches. But I'm going to have that extra little 3 8s left over. And now I come back to my total length of 5 3/8. Okay, it's 2 different ways to kind of work with it. One, if you actually had the measuring tape in front of you, versus one, if we're trying to calculate that sum, that total, maybe on a scrap piece of paper on the side in the shop. Okay, I want to give you a chance to play around with C. I'm asking you to do a different operation on C. So it might look a little uglier. It might add a little extra snag. But I want you to give it a shot. Okay? I want you to pause the video now. Okay, we're back. I'm going to erase my measuring tape version. And what I'm going to do is not lose context. So I'm going to try to tackle this the same way as what we see our solution in B. I can first put together my whole number of inches. I got 5 and a bit minus 2 and a bit. So that is going to give me 3 full inches. But now what I need to do is I need to subtract my bits. So I started off with a quarter, and then I have to subtract 16ths. So my common sized bit on that would be breaking it up into 16ths. I could now change quarters into 16ths by multiplying by 4. You can see my blue fraction right now is equal to 1/4. I now need to subtract my 9/16. Okay, I'm going to put brackets around so we can see it. That is going to get me to 3, and here's the weird part, -5/16. You'll notice that when I subtracted 9/16 from a quarter, I was taking away more than what I had. My 9/16 is a little more than 1/2 inch. My 1/4 of an inch is clearly less than that. So that's what left me with that negative. So how do I adjust? Well, now what I need to do is I need to backtrack. So I'm going to draw my ruler in a way so we can have a little context. If I was to draw my ruler, then this might be my 1 inch, this might be my 2 inches, and this might be my 3 inches. What that now says is I would be at 3 inches if I match my red, but I need to backtrack 5/16. I got to take away that 5/16. Well, if I'm going to go 5/16 back, then really what I'm looking for is figuring out how far into that second inch do I have. After my 2-inch measurement, if I take away 5/16, then that would leave me with 11/16. Can you take a peek and just notice that my green fraction and my blue fraction would add together to give me 16/16, which is my whole inch. So what I really just found then is my total sum is actually the 2 full inches I have and 11/16 of an inch into that next inch. I should say that third inch. There you go. Okay, I'm hoping that that helps you to give you a little context as to how to work with real life measurements, like measurements with a context, with an application. Okay, taking a look at our next problem, I just want to give you some context as to where those 3 previous problems actually arise in real life. So let's say that I'm going to, attach a board to a wall, let's say. I'm going to attach a board to a shelving unit. And I need that to be sturdy enough. It's got to be solid. Well, if I took my board, and just bear with me on a pretty crude diagram, and I looked at it from the side, here comes my nail. And I'm going to now hammer that nail through the orange board and into the wall. Well, what that says then is, in order for that nail to be sturdy enough to make sure that it holds that board to the wall, if it just went through like a little bit, then it's really easy for that board and any weight that gets put on that board to put pressure on that board to just peel off and fall off. I need that nail to go through that board far enough that it provides a really good anchor. So what the problem says is, my board is 1 3/8 inches thick, and the nail has to extend at least 1 1/4 inches into the wall to provide a good anchor. Okay, this is a calculation you've got to make at times. How far do I need to get that screw to go into the wall to be able to properly anchor? Therefore, what length of screw do I need to build whatever I'm building? So you don't need the diagram, but from a context, what you need to figure out then is, what is 1 3/8 inches plus 1 1/4 inches? There's the context. Okay, now that you can see it in red, I think we get an opportunity to go ahead and try some of the mechanics we just worked on. So I want you to go ahead, pause the video, give it a shot. Okay, pause it now. Okay, we're back. I want you to see how I could just manipulate this problem with the way it's written and save a little bit of time. We should be good that I'm going to go through and I'm going to add together right now my whole inches. 1 inch plus 1 inch is 2 inches. But now I got to add my bits, my fractions of an inch. Well, I already look at that 1/4 inch. And when you take a look at that 1/4 inch, sorry, I'm just going to resize that, then I can change that 1/4 into 1/8 by multiplying it by 2. So that's what I'm going to do. I'm going to actually just multiply my denominator by 2. That means I've got to multiply my top by 2. And so I'm going to view that second dimension, that second length, as 1 2/8. That makes it really easy for me right now to put together my same size lengths. There's my 5/8, and I am good. Okay, hopefully that's what we got down to, and we're feeling a little more comfortable working with some actual dimensions and working with some imperial measurement. Okay, let's try another one. I'd like you to take a look at the problem that you see now on your page, and this is one where things get quite a bit uglier. When we work our way through a lot of these measurement problems, it's really nice to work through a metric measuring system because everything's base 10. And so your numbers stay nice and neat. Well, you start to work through with some imperial stuff and things get a little uglier. And now you start to work through finding the area of a cylinder and things might get even uglier. I want to show you guys how you can go through and work with this. It's going to involve more approximates than what we're used to. Okay, I could treat this like the same problem we always would, like a metric problem. If I said, okay, how do I find the surface area of a cylinder? Well, I actually want to give you a moment to just practice a little bit. Do you know how to build the area for that cylinder? So pause the video now and jot down how you would calculate that. Okay, we're back. So if you're trying to build a formula relationship to it, I'm hoping we can look at the fact we would have 2 of the circles on the top and the bottom, plus the label on the can. Well, the label would be the circumference of the can times the height of the can. And there's us building our relationship. Okay, please don't copy this down. But this is what it would look like if we treated it the same as metric. You would now say, okay, I have to sub in my radius. Well, 2 5/8. Well, if I'm going to look for my radius then, my radius would have to be half that distance. Well, half of 2 is nice and easy. It's 1. Half of 5/8, I can't divide 5 by 2 evenly. So I'd have to change my units. Rather than working with 5 in 8ths, I'm going to work with it in 16ths. So that would be 10 16ths as the same dimension, of which I could now take half of that, and you notice we get back to the 5. That is the nice part about Imperial, what we talked about at the very beginning today, of you can always just take half of something pretty quickly. So what my radius would be then would be 1 5/16. Okay, 1 5/16 squared plus 2 times pi times 1 5/16 times 3 3/4. And you look at that orange line, you go, oh my goodness, that is ugly. And I'm going to tell you it is. So depending on how close you need to get this actual measurement, like how exact do you have to be for your surface area, then we end up having different ways through this. You could end up going through and taking that orange, and again, you're not copying this down, but you could now say, okay, I am going to change all of my mixed numbers into improper fractions and now just treat this as one big fraction expression. You know, square your 21/16, then go through, multiply in the second term, go through and simplify. But it's just really one big fraction expression. If you had to be as exact as possible, that orange is what you would do. Notice there's no rounding in there, so we are keeping things as perfect for as long as we can. Okay, for most of us, when we're going through and we're trying to find the surface area of that, absolute exactness, if that's the way to say it, isn't really our goal. So what I'm going to focus in on with you is how we could come up with an approximate value for that surface area. So what I'm going to do then is I'm going to erase all that orange. And I'm going to get rid of all of that good work we just did, but I'm hoping that it made a lot of sense to you. Now what I'm going to do is I'm going to work through with some approximates. So if we take a look at the height of the can and we said, well, hey, 3/4, if I had to change 3/4, then that is a 0.75. We could view it in decimal form. We could then do the same thing on our radius, that you could take that 1 5/16 and convert that into a decimal. Or what you could do is you could take the existing diameter. That diameter of 2 5/8 is really just 2.625 inches. You'll notice we get a lot of decimals when we do that. Now, we're trying to be as exact as possible. So what that means then is my radius halfway would be half of that. So my radius is then 1.3125. Oh my goodness, is that just getting uglier? Okay, but those are going to be the values we're going to sub in. Now, because my radius is going to be such an ugly number that when I go through and I square that, or I now take that really ugly radius number and I multiply it by maybe not so ugly height, but still uglier, you can see that you're going to get some huge decimals as you go. Okay, our job is to try to minimize the rounding when we calculate. We want to be as exact as what we can be while still making things functionally easy to work with. So what we're going to have to do is do all of these operations at the same time within each term. So you are going to take the entire first term and calculate it. Okay, that means that we've got to follow BEDMAS within that first term. So you are going to take 1.3125 and square it, then multiply it by 2 and multiply it by our pi approximate. Now, that's going to cause two rounding issues. Number one, we've already subbed in approximate for pi. But secondly, you're going to have to round that thing off because you're going to get a super long, ugly decimal across your screen. I want you to work on your keying sequence, but when we do, we should get down to approximately 10.82. Remember our rounding rules. If there is no rounding rule in the problem, then we're going to round to 2 decimal places if there isn't an inherent rounding rule. Okay, we now have to do the same thing with the red term. So we're going to calculate our 2 times our 3.14 times our radius times our height, and we're going to get another big ugly decimal. When we do, we're going to round off to our 2 decimal places. You'll notice at the beginning of that line, I've marked that as an approximate to show that rounding has occurred. But now on my next line, I don't need to round those two values. My 10.82 and my 30.93, I can give an exact value for that of 41.75 square inches. And that's how we can work through a pretty exact solution. Rounding has occurred, you see it labeled. For us to go through and deal with an exact value, it is not good. But if we were to go through and actually use that soup can, and we wanted to know, well, how much is it going to cost us for the material on that soup can? Well, we've got a pretty decent number in the 41.75 square inches to work with. Okay, I'm hoping that problem shows you how we can functionally go through and deal with some measurement issues in imperial measurement. Okay, one last problem for us. Now, okay, this is going to be your problem that is going to be your practical problem. I just want you to take a look at this. The problem says if a room measures, and it gives us the measurements to it, so I'm going to draw this big rectangle. I don't want you to right yet. It tells me that is 9 feet 5 inches by 8 feet 4 inches, and you can now see my foot markers on there. Single tick equals feet, double tick equals inches. Well, there's my room. And the question asked me, what is the area of the floor in feet squared, or in square feet? I want you to imagine this problem as a very practical one. You say have a bedroom, decent sized bedroom, 8 feet 4 inches by 9 feet 5 inches, and you need to figure out how much carpet do you need for that room? Or how much flooring do you need for that room? Well, that's the problem we're asking. You took out a tape measure, you're able to measure it, you got accurate measurements in 9 feet 5 inches and 8 feet 4 inches, and now you have to be able to walk into that store to buy your good, your flooring, with an accurate measurement. So let's take a look at the room. Now, when we see that we've got 9 feet 5 inches and 8 feet 4 inches, we look at that, and those are two different units. That sometimes what can help is for us to break it apart into feet. So let's take a look at the bottom dimension, the 9 feet 5 inches. If we wanted to think about that as 9 feet and then 5/12 of another foot, 5 inches out of my 12 inches. Be very careful. There is a super common mistake where we start to think about the idea as, no, but it's like 9.5. Like 9 feet 5 inches, it'd be 9.5. Be careful. But like 8.8 or 8 feet 4 inches is 8.4. Be careful. That's assuming base 10. But there's 12 inches in a foot. So even if we were to look at the 9.5, 0.5 of a foot would be 6 inches. 6 inches. So as we're taking a peek at that then, I think it's important for us to kind of analyze, hold on, maybe let's write it all in the same unit. So I'm going to get rid of all of that stuff that I just jotted down, and we should be good then to be able to do the same thing with 8 feet 4 inches. I could now change that into 8 feet and then 4 inches out of 12. Okay, I would hesitate to bother reducing that fraction. Like you look at that last one I just wrote down and you go 4/12, and well, that's 1/3 of a foot. But I don't know if we gain anything by that. I want to show you why. If we have to now go through and find the area of that floor, well, then we're going to take our area, and we know our area is one dimension times the other. So we go ahead and we say, well, then that's 9 feet 5 out of 12 times my 8 feet with another little bit of 4 out of 12. And we tend to put our dimensions that way. 9 feet 5 inches by 8 feet 4 inches. Now, you can go ahead and you can calculate that straight from there if you wish. It's actually the most accurate way for us to get it. I'm going to put down in green how you should be punching that into your calculator. We need to be very conscious of bed mass. If I punch in 9 plus my bit, then that's going to calculate correctly. Most of our calculators will follow bed mass, so it will ensure that you do that division first and then do the adding last. So that green amount is going to work out to a decimal approximate of 9 feet 5 inches. The problem becomes, as soon as you now go times, that operation is now going to goof up what you're intending to calculate. You're going to now go times 8, and it's going to do that 8 operation first before it does the add, and now what we think we're calculating, our device isn't. That blue is all wrong. So, my advice to you, don't even punch in the first one the way it is. It's going to look weird, but I'm going to actually punch it in backwards. For most of us on our calculator, if we calculate our 5 divided by 12, and then we add that on to our 9 full feet, use the brackets to do the same thing. Now I will calculate my 4 divided by 12 and add on my 8 feet. And if I punch that green into my calculator will do what I want it to do. You notice by putting in those brackets, I maintain my order of operations. Now my device works. I'm going to ask you to get a little bit of practice on your keying sequence and make sure that you can come up with an approximate of 78.47 square feet. And you can choose to write it the way I just wrote it, or you can choose to write it as feet squared. Either unit is fine. You make sure that your keying sequence nails that down and you are good. So if this was your room in your house and you needed to lay your flooring, you'd be walking into that store saying, okay, I need as exact as possible 78.47 square feet. Now, when you go and you buy some stuff, you always like to have a little extra. It might be a bit of a common thing for us to add on 10% extra in terms of materials. But those sorts, at least you know that as accurate as possible, that is the space on the floor. Okay, I want to walk through this one other way, because there is another way that you could calculate the area of that floor. And it's actually a really nice way. The numbers are going to get big, but then there's a common mistake that we could make as we try to change it into something a little more meaningful. I want to walk through that exact same diagram, but I'm going to provide, this time, a blue solution. What I want you to do is to zero in on the purple. That is, I want you to say, well, if I've got different units, why don't I turn it into the same units? And similar to what I would have done if I had meters and centimeters, I'm going to change it into the smallest units possible. Okay, I'm going to change my 9 feet 5 inches into all inches. Okay, well, 9 feet, and there's 12 inches in every foot, so 9 times 12 is 108. Add on my 5, there is 113 inches. Well, I could do the same thing with the other dimension. I go ahead and I calculate 8 feet. Well, 8 feet in inches would be 96 inches. Add on my 4. This dimension would be 100 inches. And what I could do now is I could go ahead and I could calculate the area of the room in inches, the same units. And notice I got rid of all my fractions. Okay, I want you to look at my blue solution. My blue solution then would look like, well, my area is 113 by 100. Okay, that's going to give me a big number, but a very manageable number, 11,300. Well, now it's important for us to note I have different units. So if I went to put my units on that one, then I'm going to have square inches. Or if you wish, we could end up writing that as inches squared. Okay, you take a look at that blue. That's not going to be the way that you would go in to order your dimensions or order your material. Not at all. And I would argue for a lot of us, even with the limited experience we may have with imperial measurement, 78 square feet is going to become something that you are more comfortable with than trying to estimate what 11,300 square inches looks like. Okay, so how can we piece that together? Well, the important part for us, I'm just going to adjust my spacing there. I'd like you to take a look at that 11,300 square inches. And let's convert it into square feet. Well, how many inches are in a foot? There's 12. So if I took my 11,300 and I divide it by 12, then that's going to give me my quantity of square feet. And so if I just adjust my spacing a little bit and I make that calculation, I'm going to get down to 941.67 square feet. Nice. Okay, we have a major problem. I want you to take a look at my red, and I want you to take a look at my orange. I have different answers. It's not like the size of my room changed just because I changed units. So what happened? Okay, I'm going to get to that in a moment. Can I just get your attention on something that's going to be super important? My proper calculation was about 78 square feet. If I walked into a store and thought that I needed 941 square feet of material, I am probably going to be throwing away thousands of dollars because of my math error, because of my calculation error. That is a super costly mistake. It is so important for us, from a financial standpoint, to not be throwing away money, hard-earned money, because we make a calculation error. So maybe you can see our mistake that we made. I'm going to hop off on the side so we can see where it went. I'm going to get rid of that orange because in all honesty, I don't need it. I've got the blue. But the orange was where I made my mistake. So what I'm going to do is I'm going to come back over to the orange on the left. And I'm going to go back to something that's super important for us. If I took a look at my red dimensions now, and I converted each one of those mixed numbers into an improper fraction, I'm still keeping it in feet. But what I'm doing is I'm kind of eliminating my mixed number. So I could view that as 113 inches out of 12 inches. My 12 times my 9 is 108, add on my 5, 113, but it's 113 out of 12. And I could do the same thing with my red up on the right. That would be 100 out of 12. Those both are in feet. So now if I went to calculate my area, I'm going to take my 113 twelfths times my 100 twelfths, and that's going to give me 11,300, and look at what my denominator is. It's 12 times 12, which is 144. And now if I go and I calculate that value, hey, look what I get. I get a 78.47, and there is my correct way to calculate it. So what was my mistake? Okay, last thing on this problem. If I have linear feet, remember, that's different than square feet. So if I look at that diagram and I looked at that as 1 foot by 1 foot, then my green square represents 1 square foot. But if I view that as 12 inches by 12 inches, the same shape, maybe I shouldn't have even drawn it bigger, the same shape, then 12 by 12 is 144 square inches. This was our changing measurement issue that we addressed earlier. I have to make sure that I don't treat squared units the same as I do linear. So I'm going to erase my little diagrams there, and I just want to make a quick little note. If I need to change square inches into square feet, then I have to divide by 12 to change one dimension, but then I also have to divide by 12 again to change the other dimension. Or, the fast way on that, just divide by 144 and you are good. Okay, I'm hoping that helps you, and I'm hoping that you can see that that is a very practical situation that you're probably going to encounter later on in life. Okay, your job now, jump in and get some practice and make sure you are comfortable working with imperial measurements. Okay, best of luck.